1A. Which type of water is safe to drink? Tick one box. So scanning through, sewage added to water would definitely not make it safe to drink, so we can rule that one out immediately. If water's been contaminated by flow from a farm or flow from industry, again, that could make it dangerous, and therefore we don't want to drink that. Potable water is water that is safe to drink. It doesn't necessarily mean that there's no dissolved particles in there or even no bacteria, but it means that they're at low enough concentrations that they won't do us any harm. So potable water is water that is safe to drink. And if we just check with our final answer, seawater would be very dangerous to drink. The high levels of salt dissolved in it would be very dangerous to us and could kill us by harming our kidneys. So seawater, again, would not be safe to drink at all. B, identify one substance that can be added to water to sterilize it. So to get rid of bacteria that are going to cause problems, we could add, let's have a look. So tick one box. Oxygen molecules. Well, oxygen molecules have the formula O2. Now, they wouldn't sterilize the water. Ozone, which is oxygen, but in a molecule with 3 oxygen atoms joined together, that would do the trick, but that is not one of the options. So oxygen molecules is no. Sugar wouldn't sterilize the water. It'd make it taste sweeter, but it wouldn't sterilize it, so that can be removed. Adding bacteria to it wouldn't sterilize it. In fact, we're sterilizing the water to get rid of the bacteria that could cause diseases. So it can't be bacteria. And the final answer, chlorine, looks like a good one. So chlorine in low concentrations would be added to the water to kill the bacteria so that they were only present in very low quantities so that the water was safe to drink. So our answer is chlorine. C, suggest why fluoride ions can be added to drinking water. Well, in some places, there is naturally fluoride ions dissolved into the water because the rainwater is flowed through rocks or soils that contain fluoride ions. In other places, that's not the case. So in those areas, fluoride can be added to the drinking water to stop there being so much tooth decay. So it helps to protect our teeth and can be added particularly in areas where there's less fluoride getting into the water naturally. Finally, D, pure water can be extracted from salty water by distillation. Describe in terms of the changes of state how pure water can be extracted from salty water. So if we look to the side, we can see a diagram with the water molecules and the salt particles drawn out. Now, water will, when it's heated, change from a liquid to a gas before the salt will change state. So in our first step, we want to explain that the water, when it's heated, is going to evaporate. So it's important in our answer that we talk about the water evaporating rather than the salty water, which would be incorrect. It's only the water part that's going to evaporate. As it moves through the distillation apparatus, it would get then to the condenser, where the water vapor is cooled down and it condenses from water vapor back to liquid water. So in terms of changes of state, the water evaporates. It goes from a liquid to a gas when it's heated. And then the water vapor in the condenser, the water vapor would condense. And when it condenses, it goes in the reverse direction. It goes from a gas back to a liquid. So our first mark would be for the first change of state, and our second mark for our second change of state.